Okay, so for the next 2 hours or so, we're going to go through the hand calculations of stud rail design. For the most part, stud rails are used across the country. To the best of my knowledge, I think they're primarily more, I would say, prevalent, let's say, on the West Coast than the East Coast, especially for certain applications, but very popular for flat plates, obviously. Rebar rebar concrete or post tensioning. They work equally well in both, but considering they're relatively new in the reinforced concrete realm, if you compare that relative to concrete, PT, or rebar, which has been around for a number of years, stud rails for punching shear are, relatively new system. With that said, there's not a tremendous amount of documentation that I'm aware of. I could be wrong. I didn't do a huge literature search, but in textbooks for, Concrete 101 courses in college or even advanced in graduate school, I don't believe there's a tremendous amount of documentation on how to actually design the stud rails or the numerics involved and stuff like that. Most of the time, in my experience, the stud rails are usually designed by proprietary software. And that's, started back in the day, let's say 20 years ago when they came, I think, much more prevalent than they were previously. So again, it wasn't like we just designed the stud rails all of a sudden. It was a lot of times it was a widget that people purchased, obviously, and there was a software to do it for you with not a whole lot of explanation of what the software was doing. Stud rails themselves are primarily used for punching shear resistance. They can be used like any other piece of rebar as you see fit, but for the most part, it is punching shear resistance. The reason I bring that up is because that's slightly different than caps or drop panels, which can be used for a couple different ways, primarily punching and then obviously flexure and deflection control. But for the most part, stud rails are primarily just used for punching shear resistance. As I mentioned, they have multiple uses that can be used. Usually, aside from the punching shear resistance, we have used them for PT band anchorages for a long time. As I'll show you in a photograph later, there is an ACI section to basically every time you have a band anchorage, the ACI code 318 has a figure that shows a U-bar. And it's been like that since, 20 or 30 years from now, whatever it's been. But for the most part, people on the West Coast, I would say, use band anchorages out of stud rails because they fit a lot better. They're easier to install, and they don't have the conflict with the perpendicular rebar that a U-bar will have. But the interesting thing is they're not really shown that way in the code, even though they are, primarily used for all slabs less than about 12 inches in my neck of the woods. So if you do see that, it's a very typical use. For PT, obviously you wouldn't use it for rebar in that condition, but it's very popular way to do things. When we first started using stud rails, there were very few actual stud rail products. There was Dacon, who I think is also called Jordel, if I'm pronouncing that correctly. If not, I apologize. They were one of the first ones out of Canada, but there was relatively few of them. And the reason I bring that up is because when we first started using stud rails on flat plates instead of caps, and typically in my experience, and this is a Brian thing, stud rails work better when it's single level loading, meaning a garage, an apartment, a hotel, an office building, whatever it is, but it's a single level. Now, if you have a podium type structure or something where you are substantially increasing the slab thickness based upon load, just not based upon span, then I typically think that stud rails aren't maybe the best choice, that you should go with caps. But, back in the day, there was not a whole lot of options out there. The reason I bring that up is when we first started doing stud rails, let's say on garages or hotels and apartments and stuff like that, a lot of miscellaneous metal subs would take some Nelson PSR studs, slap them on a rail and call it good and save, a very large amount of money on bigger projects. And when we would reject those It got very confrontational very fast. So there must have been a lot of money to be saved. And they look very simple. When I show you the photographs, if you have never seen one, it's effectively a stud welded to a rail. The problem is when you just have random studs, let's say, to be dramatic, welded to a rail, there's no assembly report. There's no way to justify the strength of the system itself. The pieces and parts, fine, whatever that is. But the actual assembly, the whole widget, is not documented. So that puts all the legal responsibility on you as the engineer of record if you accept that. So what we do now, hindsight being 2020, is that we provide the documentation or the specifications for the stud rails that we want, the minimum strength and all that kind of stuff, and then just say, but they also have to have an assembly report. And that usually ends it. Now, if you're new to stud rails or in your neck of the woods, they're just starting to use PT flat plates or rebar flat plates, whatever it is, just be wary of that. Do not allow someone just to slap studs on a rail and call it good.